A and B, they are two stations on a straight line which are 975 kilometers apart. So therefore, the distance between two places A and B, that is given as 975 kilometers. So as in the previous problem, the speeds of two trains started from A and B at the same time towards each other. They are 40 and 25. The speeds of two trains started from A and B at the same time towards each other. They are 40 and 25 kilometers per hour respectively, right? So the distance between A and B, that is given as 975. The speeds of the two vehicles, they are 40 and 25, and moreover they start at the same time and they are running towards each other, right? And the question is, at what distance from the second station they will meet each other? At what distance from the second station they will meet each other? So in this problem, the two vehicles, they start at the same time. The distance is given as 975 kilometers. Next, again the same concept. The two vehicles, they are running with the speeds 40 and 25, and they are running in the opposite direction. So then what is the formula for relative speed? It is S1 plus S2. 40 plus 25, that is 65. So that is the data available. Distance is given as 975. The two vehicles are running in opposite direction. The formula for relative speed is S1 plus S2, 40 plus 25, 65. The formula for a time period is distance by speed. Distance by speed. So no doubt they will meet after 15 hours. They will meet after 15 hours. But the question is, at what distance from the second station will the two vehicles meet? At what distance from the second station the two vehicles meet, or they require the distance covered by the second vehicle in 15 hours. The distance covered by the second vehicle in 15 hours. But what is the speed of the second vehicle? 25. The speed of the second vehicle is 25 and the time of journey is 15 hours. Distance formula, speed into time. So therefore, at a distance of 375 kilometers from the second station, they will meet each other. The distance between two places is 975. The two vehicles are running in opposite direction, and the formula for relative speed is S1 plus S2, so 40 plus 25. So by using these two quantities, we can calculate the time. The formula for a time period is distance by speed. So no doubt they will meet after 15 hours. These two vehicles, they meet at the particular point. They meet at the particular point in 15 hours. But you have to calculate at what distance from the second place they will meet each other. Or in other words, what is the distance covered by the second vehicle in 15 hours. The speed of the second vehicle is 25. The time period is 15 hours. So therefore, it can travel 375 kilometers distance. So at a distance of 375 kilometers from the second station, they will meet each other. So here we have to consider the concept of relative speed. And the next one, the distance between A and B, that is 356 kilometers. The distance between A and B, that is 356 kilometers. A train starts from A to B at 8 AM at a speed of 28 kilometers per hour. Another train starts from B to A at 10 AM at a speed of 32 kilometers per hour. So the given data is the distance between A and B, that is 356 kilometers. The first vehicle starts at 8 o'clock with a speed of 28, and the second vehicle started at 10 o'clock with a speed of 32. And of course, the two vehicles are moving in opposite direction. They are running towards each other. But in this case, there is a difference in the time of their start. The first vehicle started at 8 o'clock. The second vehicle started at 10 o'clock. And there is a difference of 2 hours time, right? By the time the second vehicle starts its chasing, or let us find out the position as at 10 o'clock. So let us calculate the latest position. The first vehicle started at 8 o'clock, the second vehicle started at 10 o'clock. So for the first 2 hours, the first vehicle can travel 56 kilometers because the speed is 28 km per hour. The speed is 28 km per hour. In 2 hours, it can cover 56 kilometers and it continues its journey. So by the time the second vehicle start, that is at 10 o'clock, the distance between two vehicles, it cannot be 356 because the first vehicle already travelled for 2 hours. The first vehicle already travelled 56 kilometers. So let us decide the position as at 10 o'clock. Exactly at 10 o'clock, the distance between the two vehicles will be 300 kilometers only, because this is 356 minus 56. So exactly at 10 o'clock they are separated by 300 kilometers. Next, at 10 o'clock the two vehicles are running towards each other with the speeds 28, 32. Then what is the formula for relative speed? S1 plus S2, because they are moving in opposite direction. S1 plus S2, 28 plus 32, so 60. So these are the two quantities. By the time the second vehicle start, so exactly at 10 o'clock, the first vehicle travelled for 2 hours or it travelled for 56 kilometers. So exactly at 10 o'clock, the distance can be 356 minus 56, that is 300. Exactly at 10 o'clock, they are moving in opposite direction with the speeds S1 and S2. So 28 plus 32. So therefore, these two vehicles, they meet after 5 hours. These two vehicles, they meet after 5 hours. This 5 hours is calculated with respect to 10 o'clock. So you have to calculate 5 hours after 10 o'clock. 10 plus 5, 15, or equal to 3 p.m. So when will they meet? The two vehicles, they meet after 5 hours from 10 o'clock. So 5 hours from 10 o'clock means 15, or simply saying 3 p.m. So no doubt these two vehicles, they meet at 3 p.m. Same problem, same model, just for the sake of practice. Two cars start from A, two cars start from A towards B. It is not one from A to B and the other from B to A. That is very clear. Two cars start from A towards B. One at 5 a.m. with a speed of 18 km per hour and the other at 7 a.m. at a speed of 27 km per hour. So in this problem, two vehicles, they are moving from A to B. So that is self-evident, they are moving in same direction. But there is a difference in the time of the start. The first vehicle started at 5 o'clock with a speed of 18. The second vehicle started at 7 o'clock with a speed of 27. And the question is, at what time will the two cars meet? So in this case, the two vehicles start at a different time. The first one at 5 o'clock and the second one at 7 o'clock. So let us consider the position as at the starting of the second vehicle. So let us consider the position as at the starting of the second vehicle. So let us consider the position at 7 o'clock. The first vehicle started at 5 o'clock and during this 2 hours time, it can advance a distance of 36 kilometers. What is the speed of the first vehicle? 18 km per hour. 18 km per hour. So in 1 hour it can travel 18 kilometers. Therefore in 2 hours it can travel 36 kilometers. So by the time the second vehicle start, the first vehicle already covered 36 kilometers and they continue their journey. So exactly at 7 o'clock, the first vehicle travelled for 36 kilometers and the second vehicle started at this place. So exactly at 7 o'clock, the distance between the two vehicles will be equal to 36. Next, at 7 o'clock, the two vehicles they are running in same direction. Then what is the formula for relative speed? S1 minus S2. S1 minus S2. It is 27 minus 18. 9. So in the first 2 hours, the first vehicle travelled for 36 kilometers and it continued its journey. So by the time the second vehicle start, the first vehicle advances for 36. So exactly at 7 o'clock, the distance between them will be 36. And moreover, the two vehicles are running in the same direction. The relative speed is S1 minus S2. So 27 minus 18. So by using these two quantities, we can calculate the time period as 4 hours. It is not 4 p.m., 4 hours. It is 4 hours from 7 o'clock. Exactly at 11 o'clock, these two vehicles they meet each other. So time period is 4 hours and this is from 7 o'clock. So therefore these two vehicles they meet at 11 a.m. because the two vehicles are moving in the same direction. The speed of the second vehicle is more than that of the first one. So therefore the second vehicle can overtake the first vehicle at 11 o'clock. So like that we have to consider the concepts of relative speed, right? In the next class we can go for another topic.